Are we live? Are we live? Are we live?
Yes, I think so.
All right.
Yeah.
Let's get this started. So, the big story this week is China. The World Robot Conference just wrapped in Beijing, but the World Humanoid Robot Games are still underway as we speak. We've already seen humanoid robots run 100 meters faster than Usain Bolt. Clearly, also clear a standing high jump that beats the human record and take the 400 meters gold in 38 seconds. So, what does this acceleration mean for the rest of the industry? Also on the docket for today's bot report, ultra-realistic bionics, new progress in dexterous manipulation, whole body control breakthroughs, and a few consumer and policy updates worth watching. We have a star panel on this live stream for this bot report. Sarah Filipcic is the founder and executive director of the Institute for Humane Robotics. Kimati Richards, a robotics founder of 10 Things, and he's also an NVIDIA Omniverse ambassador. Scott Walter, he's a mechanical and aerospace engineer, of course, and a two-time founder of robotics companies. You know him as the bot sensei to the internet. Gustav Anderson, a hand surgeon and associate professor of anatomy in northern Sweden. And Behzad Farimani has been designing humanoids and other service robots for well over a decade now. He's also advising startups and investors on the robot product roadmap. So welcome, everybody. It's great to have you on for this bot report. We've got a lot to cover.
Yes, and we are live. Check that out.
Bravo.
Bravo. To see how we look.
Yeah. All right. So first of all, Sarah and Kimati, this is your first time with us on bot report. So welcome. Great to have you, Sarah.
Thank you. Thank you.
You've been doing some fantastic work. Can you just maybe kick us off by giving the audience a very quick introduction so we know where you're coming from?
Yeah, of course. Hi, everyone. My name is Sarah Filipcic. I'm originally from Croatia, but I am living in between Japan and United States. My specialization is in technology's impact on child's development, and I've been building companies in this space for the last 8 years. And when I lived in San Francisco building my prior company, I was observing that the same consequences that happen on the mental health and well-being of youth with social media and smartphones and AI companions are about to happen within the robotic space as well. So this time I wanted to be more proactive, and I decided to move to Japan, the country that has around 10 years of data on coexistence in between humans and machines, including research on how having a robot in a household is impacting development of children. I decided to relocate, and so I've been living in Japan for almost last 1 year, and did a lot of research on like cross-cultural differences in human-machine relationships, and that work prompted the founding of the Institute for Humane Robotics. And today we are an independent research organization and a standards body, and we are focusing on robots that are entering human environments, specializing in any child-facing, household, education, and healthcare. So we directly work with robotics companies, helping them build their psychosocial safety layer of their technology, as well as doing research in-house and with our university partners. And then everything that we learn from that, we are translating into policy. So we work already with lobbying company in Washington, D.C. on creating a new regulation on how to create standards and create a more safer technology for the future of humanity.
Fantastic. And Kimate, hello to your lovely dog. Next time, please bring him on because we love a show and tell, but let the audience know who you are and everything that you do. We've just had a chat with you that was published on the channel. So it's great to have you back, and I'm looking forward to
I have several dogs, and some of them are, they have actuators that are electronic in nature. So tell me which dogs we want to bring.
Bring them all. Bring them all.
Kimati Richards, and like Sarah, I have been in the humanoid space for a bit, also focused on human interaction with robots. We are really focused on elder care robots at the moment, and looking forward to our own futures of having better care in that space. And so it's a space that not many companies are looking at. It's probably one of those spaces that doesn't. It's not going to be billions of robots on day one. We're going to start very small and understand, how we can impact quality of life as we all age. One area that we're focused on is memory care. So, people with Alzheimer's and dementia. I've had members of my family, and I'm probably marching toward that same, future. So we're focused on those kinds of things, bringing robots into spaces to kind of just get people acclimated to them, and at some point bring those, further into senior living communities, definitely hospitals and care facilities.
Cool. All right, for those who followed Over the Horizon and our bot reports, you already are familiar with Scott Walter, Gustav Vanderson, and Mehrdad Farimani. So without further ado, I think we should turn our attention to China and all the action that's been happening there. It's pretty crazy, really, because we've seen the first World Humanoid Games, was it a year back, Scott? And we kind of were stunned. We called it the Sputnik moment, the robotic Sputnik moment for America, but we've seen them. I mean, it raised the bar quite a bit, right, this time. So what do we make of what we're seeing?
Well, what we're seeing is what you can accomplish in 12 months. So the first games were last year, and there were all sorts of pitfalls and, bots falling down and not performing and everything else. And depending on how you looked at it, you were either, not impressed or you kind of ignored it. But if you were working in the space, you're already saying, oh, well, there's definitely, while a lot of room to grow, they've already come a long ways to be able to already organize a humanoid Olympics. And it's a night and day difference between this game and a year ago. Just like the half marathon, the Beijing half marathon was a difference between last year, the bots being lucky to finish, and those that finished was like 2.5 hours. And for a half marathon, not a full marathon. And this year they smashed the human world record by over 6 minutes. And so, what you can accomplish in 12 months is something else.
I think they kind of listened to you. Last time we had a big gripe about them not holding on to their line, but now they step over a little bit, but then they come back to their.
That was kind of surprising. I mean, they should have been able to stay in lane. I ran track and field, so I'm kind of picky about that, and officiated a lot of meets. But there were a couple, I guess, interesting differences. We've all seen that there was the world record in the 100, and in aeronautics, when you set a world record with an aircraft, you're expected to land it safely. The same thing with land speed records. You're expected to the same day turn around and go in the opposite direction to prove it wasn't a fluke. And in this case, the robots seem to be really good at accelerating, but they have no idea how to decelerate. And they're crashing into walls, and they're falling apart, and they're bursting into flames. So, I mean, to be considered a proper world record, I think you should be able to properly slow down and not fall apart. And then the other thing is, I think it's a great engineering challenge. So it's more or less like they set the world record for a bipedal machine. I wouldn't say it's for a humanoid because they don't have working hands. They've made all sorts of optimizations on it. So at some point, there are going to be these different classifications we have of like the world record for a humanoid that not only can do that, but maybe can play chess afterwards and, I don't know, make you a PBJ, something like that. Yeah, so you need to have some level of because, reduce the mass and everything, specialized actuators, get rid of some degrees of freedom. And that's what I suspect is like the guys running the 100 meters, it looks like they took away an actuator from the hip, which probably makes it a little bit hard for it to actually go in the corners. It's really designed to go straight and accelerate really fast. And the other thing you have to do is Kamati, did you ever run track and field, like the 100 meter?
I ran track and field, but I also entered a robot in last year's game, so I know all about it.
Oh, yeah, you were there.
Yeah, but the 100 meters is like, you can do a standing start. I mean, there's nothing against the rule to say you can't, but it's a huge mechanical disadvantage, right? Everyone is down there. So think about it as like these bots are doing a standing start because they actually cannot do it from the ground. And I think that'd be interesting because like you've got the transition and, you're coming from a squatted position and everything else. The other thing that I've kind of noticed that some people have commented that the running styles look a little bit different than humans. And it's like, yeah, they should. because mechanically they're completely different than us. The weight distribution, everything is completely different. So if you were critiquing the sprint form coming down the 100, they were standing up too straight, right? You should be leaning forward a little bit if you were a human. But for humanoid, maybe not. And so I wonder how optimal it was, or whether that's just kind of the best they were able to do. So for me, there's all those kind of questions of what does it really mean to be optimal with these different forms? They're not going to be, they may be using human priors, but they'd be very careful that they try to run too much like us.
Well, so, one thing, they had rules. I entered robots in this last year and the half marathon last year, and they had rules on kind of what kinds of penalties you would get if you missed certain facets of being a humanoid, if you were remotely controlled, so if you had a remote control, etc. All of those things had penalties.
Battery swapping and things like that.
Battery swapping, yeah. So they had penalties for everything. And I think I agree with you, in years from now, they're probably going to have a best overall robot where it's able to go from one event to another. And the one that they didn't really focus on, which I thought was the most interesting, was they had essentially a dexterity challenge, and they also had an overall obstacle challenge where the robot had to do multiple things, kind of like DARPA. But that was the least attended event, and I'm just like, shouldn't that be the most attended event?
Yeah, I mean, the best athlete in the world is the one who wins the decathlon.
Yes.
The fastest man in the world, fastest woman is the 100-meter, but the overall athlete, and that's a real show of dexterity, of being able to do all those things. So I agree with you. It's going to be hard to kind of, but it's still fascinating. I mean, it's like everything, is we're learning so much about the engineering here.
What I found interesting, and I know you might have a line of questioning, so I won't jump in too much, but I found it interesting that they open this up to the entire country. There isn't you don't have to be a scientist. When I was at the conference and the games, there are kids running around. Well, unfortunately, there's dangerous robots walking and running, but there were kids running around right between them the entire time. And so I found that to be fascinating, that they've embraced technology in this way, even though it might be a bit dangerous. At least everyone's getting to see it. And when I run around with robots here in the U.S., typically it's the first time people have seen them. So up close and personal, yes. and they're it's a different story.
Yeah, and right now no one really knows how they're supposed to behave around them, and eventually everyone will know. And it'll be, but we have to be careful that it won't become too blasé around them. But maybe by that time that happens, they'll be so safe you don't have to worry about it. But right now, everyone should be very careful.
Yeah, we've seen our fair share of robotic interactions with kids getting their teeth knocked out and so on. So I don't think we need too much of that.
Well, at the games last year, I was there on the floor when that robot ran a person down during the event. It kind of turned into a person and took them out. I was right there, and I didn't have my camera out. I should have, but
just think the views you would have got.
Well, I don't like to promote that stuff. Number one, we know right now. Yeah, I do have pics. I could send you some, but they're all in portrait mode, not landscape. So. But what I find interesting is we seem to have believed that the robots are ready right now. So when they do fall apart or things like that, we're always fascinated by that. But I'm just like, this is the mode we're in right now. We're building or experimenting.
It's the early days of the space race when the rockets kept blowing up on the launch pad.
They still do sometimes.
Yeah,
they do.
So from a bio or robotics point of view, I really like the jumping ones a lot. I mean, both the standing straight jump or vertical jump, but also the long jump. I mean, would that be easier than a running one, you'd say, or what do you think? Or are they more or less the same?
I did the high jump, so this is my pet peeve, is that the whole idea of the high jump is you have to cross a bar. That's what determines how high you went. And they basically were going up and saying, oh, that's where it is. And everyone's impressed it didn't take a running start, and says, that's because you don't have any forward momentum to actually go over the bar. So you do need to kind of run up and be able to do that and time it and be able to cross the bar. And the thing about the high jump is you can cross the bar and your center of gravity can go below it. That's the whole technique right there, is to do it. So yeah, it's, I mean, obviously we have technology that can kind of measure these things. That it is very impressive. I mean, we've seen what Ronaldo has been able to do for vertical, which is like absolutely insane. And some basketball players, and I'm sure in some way those were like their own world records. But yeah, to formally do the high jump, you have to cross the bar, just like with the pole vault and everything else. So it's a lot about technique.
My one peeve about this whole thing is I can create a robot that can do any one singular thing. Even when we did the half marathon robot as a contract, we fully optimized the robot to just run a half marathon. As a matter of fact, that one didn't even have compute to know where it was at in real space. It just knew how to, it was running.
And it showed.
Yeah. Yeah, what I'm saying. So like we can create something that can do a singular task very well, or we can combine some of these techniques that others are using and make a more optimal robot. So I do want to see an all-around event one day where there's a robot that can compete in every event. The Tenkung, I guess they call it UB Tech Walker. That robot can do multiple things. It can run and it can jump, but it also, wouldn't be something that you would see in your daily life. It was so powerful that it could run through, a wall if it needed to.
Yeah, but at the same time, it's great to see that they're optimizing for different parameters that we normally wouldn't for home use, and really pressing a lot of areas that we normally would not in engineering, or exploring everything. It's like those sprinter bots we're all using basically the Blade Runner kind of style. And everyone always asks me, it's like, do you really need an ankle? Why don't they do this? Why don't they do that? And I'm like, yeah, why don't they? Let's check it out. And you saw there was two versions there, which is rather interesting. The Sprint, there's one that was like kind of the pure Blade Runner. And there's another one that looked like it was a hybrid between that and having kind of an actuated ankle. And the expectation is like the one that doesn't have the actuated ankle is probably going to win because, it's got a lower mass and all that. And he was faster out of the blocks, but the one that actually ended up winning was the one that was actuated. So it seemed like you want to do something to kind of change maybe the angle of attack. I'm not exactly sure why, but there's obviously some sort of theory on how you can control it a little bit. And the fact that they're not using exactly the same format or to come up with the different results, I think is kind of fascinating. And that's how we push the technology ahead. Eventually, it might make it into the bots that come into our homes, but for now, probably not.
The engineering isn't done on the Blade, by the way. We introduced that one last year, and it's just there are too many. Introducing the technology and getting to the point where it's optimized are two different things, and we're not even close to that yet. And I think if we enter one next year, we'll be better off.
Yeah.
But I love the fact that they're doing this out in public, and they're comfortable showing everything, warts and all.
That's the fun part, isn't it? That they fail. But what I wanted to add was something that we also talked during the half marathon, and that was the point that the point of this. Somebody also asked in the comments. So the point of all these, from the robotics standpoint, is not to make them run a half marathon or play tennis or something in the future. Is to push the robots to their limits and recognize or identify where are the failing points, basically, and also being able to develop solutions for those extreme scenarios through these games. Last year, for example, through the half marathon, we saw that they had great sophisticated cooling systems developed for these robots, which in any other scenario, we wouldn't develop cooling system for the robots except that scenario, which can be useful for later. Or here we can see that they, actually I was looking at the one with tennis, and well, as you know, I've been playing tennis for a long time. Now everybody here has a corner in the sports, but it's extremely hard to actually get it right. But they nailed the whole body control with playing tennis. And that was something that, because you have a mass, an extra mass, which is the racket, and then that would disturb the usual robot's movements and behavior. But they did it pretty well. Although on some of them, I noticed there was a weight or a counterbalance weight on the other hand as the weight of the racket. So probably they also use that technique. But it was overall, I think the tennis was impressive. The track and field had definitely a lot of improvements, but the football is, I don't, if you've all been in robotics for a long time, and we have had robot footballs forever, since those small robots called Darwin or No, they were always like in these RoboCop teams that were just playing football, and none of them, they haven't really improved in football since then. My assumption is that it's because of robot collaboration that we haven't really figured it out yet. So I don't know. As for human robot collaboration, maybe we did better than robot collaboration.
It reminded me of when my kids started playing soccer when they're like 6 or 7 years old. It was like standing all over the place, having no idea of how to play the game together, or either everyone running after the ball like a big lump, or one guy doing everything and everyone else just looking at the birds. Or
it's interesting to look into this these days. That's a good point, because in track and field or in running, basically, they nailed world records, which is a great thing. But in football, they are still playing like 4 or 5 years olds. So this difference was interesting for me. Like, how come in some sport they can be very, very good, in some sports they cannot? But Sarah, what do you think? You've been silent.
Yeah, I mean, when I was watching the videos, the observations that I was focusing on was the cultural aspect of it, and that you guys were talking about it at the beginning. What I have seen across the board now, being going in between Asia, United States, and Europe, is that the social acceptance layer is much different. And what I'm seeing in Asia throughout is that there's a lot of more emphasis on increasing social acceptance. So there are cultural and educational, and even within a healthcare, not to mention entertainment and media, emphasis on like introducing this technology into society and working on people getting used to it. So what Kimata was saying, this is something that in these games, like, you see kids being excited about it. I've heard interviews of like mother holding their like toddler, not even, like a maybe 70-month-old baby, and saying, I want my daughter to be in robotics one day. And so like there's this introduction continuously of showing that this is the future, and that this piece of teaching to normalize that future is very important. Versus in the United States, for example, like we run this experiment just recently in Central Park, and what we've seen, like I've been traveling with my robot pet from Japan, and when we were in New York, a lot of people were so afraid of it. And it's like a little toy robot, it's super cute, has adorable eyes.
Wait, hang on. You have a robot pet from Japan? It's time for show and tell.
Yes, I have it. He's right underneath me. I hope he's gonna be able to wake up. It's his sleeping time. So give me a second to try to wake him up. Yeah, he has there he is. So he sleeps 8 hours per night. So this is Lucky. Okay. Super adorable robot. Very safe. You can basically you hold him like this, you cuddle him. As you can see, he's like really tired right now because it's his sleeping time, and he's like low-key a little bit annoyed by the fact that I'm like waking him up. But so now imagine like introducing this piece of technology in United States market compared to now traveling within Europe and Asia. Like the number of people that were afraid and that were like, oh, don't record it. Like they focus on the camera aspect, and they immediately associated to like surveillance. So even like the police within the central station were like kind of having a bit of a, what is this? Like, what does it do? And we also had one meeting at like a Harvard club in New York, and like one woman came to me and she's like, move this away from me. I don't want it anywhere close to me. I don't want it to record me. I don't want to like track me and stuff like that. So we do see a lot of that in the United States, and like with some other technologies that we work with, especially humanoids. Like people in tech are super cool with it because they want to figure it out, how it works, what it can do. But outside of it, people are super afraid of it. So immediately they go to like Terminator narratives. And I think that, we can be competing against China, we as in the United States, as much as we want. But unless we focus on the cultural adoption and social acceptance layer, I don't think that we're going to.
But it's not only the United States, it's across the West, isn't it, Sarah? Because it's a cultural thing. There seems to be like a very clear propensity or willingness to, to accept innovation or try out something new in Asia and China, which, as you said, just doesn't exist in the West. And I'm wondering, is there something deeper socially that's happening there? Is it like, is Asia and China more pro science, more pro innovation, and more open to readily accepting or experimenting with newer forms of technology than the West today? And that would be insanely ironic if that were to be the case.
Can I raise my hand and answer?
Yeah, I mean, I definitely also have a lot of comments, but
Go for it.
do you want to kick off and then we can?
Yeah. So I think there's a little bit of history involved here. If you look at what was going on in China in the 1950s and 60s, where they kind of gotten rid of all of their knowledge workers. Some of them fled to the U.S., et cetera, and then they had to kind of rebuild from nothing. They embraced new technology at that point in time. They turned themselves into the manufacturing hub of the world, the low cost labor hub of the world as well. And so they're accustomed to this using technology to surpass where they are currently, where I'm not sure the rest of the world, and in Japan, some could say the same thing for Japan, in the automotive and electronics industry, they dominated for a long period of time. But this is also in the heels of World War II and kind of having to rebuild how they think. So I think if you look at those societies that have prospered on, embracing technology, they are probably the two foremost, and some can also say, South Korea is now starting to do the same thing, and a few others. It's Taipei if you go there, and so I think what we're seeing is the U.S. kind of and Europe resting on our laurels in a way and saying, hey, we've done this. Also, in the fact that a lot of the mind share, and I said this maybe a few months ago, but IROS, when I went this year, half the papers were by Chinese people or Chinese Americans. When I go to MIT, and my favorite professors, they're all Chinese Americans. They fled here from China. So I think we in a way in the U.S. have been very, very lucky to have all these immigrants come in and just bring their innovation along with we obviously have people of our own, but we had it all here. And now you're starting to see, some people stay in China, and University, Peking is amazing. Now you're starting to see it all go back there, and the people know that this is next. They need to embrace. So I'm sorry, I'll stop there. But you have to look at the history here.
Quick note to everybody that's watching us live. These are the visuals from the World Robot Conference that just wrapped in Beijing, and it just goes to the point that you were making, Kimati. If you just look at this is any exposition, any expo, right? I mean, it could be an auto expo. Instead, it's a robotics expo. And across the West, I imagine you still have a lot of interest in auto expo when it comes to cars and bikes and cool stuff like that. But then somehow robotics isn't as mainstream cool in the West as it is in China. And just look at just the range for anybody. I encourage you to just go to CGTN. This is videos that we're playing out from CGTN, and you could go to their YouTube channel and check out the range of products on display. It's pretty crazy, and there's a lot of experimentation going on. It's fun, and it's innovative, and it's crazy, and that's the culture, I guess. The difference in the culture.
I think some of this recently came to a head. So Sarah, I want to ask you, were you able to bring your robot on an airplane?
Yeah, everywhere.
Okay, that might change. I assume the battery pack size is all right, but as you know, Southwest Delta and I think United recently banned humanoids. I mean, complete ban. You can't even put them in your check bag. And I think part of it might be because they're afraid of the batteries, not realizing that most of them have swappable battery packs. You could take it out. And if you did, they do not want that up. And of course, they're way beyond the battery size. I can understand a little bit because we've seen how these robots can kind of suddenly freak out for no reason. You've got a crowded flight and someone's cute little humanoid is walking on down there and suddenly just does something like that. So from the standpoint of liability, I can understand. I can also understand it from lithium batteries. And that's always already a problem for a lot of the bots that are coming over from China. I know so many people that get there, like the Unitree bot, and they're waiting in the battery pack. So it has to be shipped differently. So that's already complicated. Then there's the other aspect with the camera on there. Is a lot of people are afraid of the surveillance. And that happened to me like in San Francisco this week of all places. We're just going from one place to another. We had a videographer with us and he had his camera out because we're just doing like a 5-minute drive. And the time to kind of break it down and everything was to be too much. And the driver said, put the camera away. He says, like, we don't need it. We just want to put it in our lap. And he was like, that's it. I cancel. Boom. And he was gone. So I think he may have thought that we were going to be filming him back there. So there's a lot of people with the pushback and flock cameras and everything else that are kind of afraid of this technology because they're afraid there's going to be a lot of surveillance. And each culture is a little bit different. So Japan people have been used to having these not just automation, but kind of robots in their environment for like 20 or 30 years. So you'll have these, they're not really kiosks. I mean, they're like a little robot that you go up and talk to that when you check in the hotel. So they've been accustomed to that from the Tomaguchis and everything else. That's sort of the same idea. China is very much used to a surveillance state. That's been around, and so they're like, just another camera doesn't matter.
No, but I think it's also they care a bit less about privacy as people in the West do. And I quickly wanted to bring this comment up from the live stream. This is TechRun 2160 saying China's robot race is to get state funding. It's not about making a robot that actually does useful work. If it is, I haven't seen it yet. It's all about kung fu moves and dancing. Well, yes and no, right?
Please
go for it.
Yeah, I vehemently disagree. And as somebody who spends a lot of time in China, we all, U.S. and China, are trying to do the same things. The difference between the U.S. and China is China has embraced all kinds of technology in any form. Like I might have talked about on the show last time that I got my Starbucks delivered on top of the Great Wall by a drone. They're testing personal eVTOLs there. They just have money to, and you're right about the state funding part. They're giving money for innovation of all types. They're embracing every bit of technology. And it just so happens both in the US and China is we do have the same goals. However, what we're doing in the US is we have maybe 3 or 4 companies that are focused on, a certain facet of robotics. And then, obviously that has goals of its own. We're doing pick and place with, all the major companies out there, Figure, Tesla, et cetera, 1X. They're doing pick and place tasks. That's the main goal. And in China, they have a proliferation of companies. So they have over 200 robotics companies now. And they're all working on small innovations that might all end up, working together at some point. But they have the same goals as we do.
Kimade, I'm curious. Do you think it's easier for someone to just launch a startup in China than in America or Europe?
100% easier. And I know Scott knows this. In China, they have these things called centers of innovation all over the country, where the government has sponsored bringing back technology to certain places because they don't want their youth just rushing into the finance world in Shenzhen or Shanghai. They want them to stay in Wuhan. They want them to stay in Hangzhou, et cetera. So I've been to, and maybe I have this video in landscape, if I can show later, but I've been to one of these where they have robotics, not just, it's a city built for startups in robotics, where they have free rent for 2 years. They have grants as well. They have shared space where everybody can work on, their technology and teleoperation, data gathering, all that stuff. And they have free housing for the employees that work there. So just imagine me, a startup founder, if you gave me 2 years of a runway, what I could do versus what I have to do on a daily basis, which is scrap for funding and talk to investors and totally not focused on the goalpost, totally focused on getting funding as the major thing that we're doing. So does China, I think, have a better answer? 100%. Like, we as founders spend so much time looking for money that the goal sometimes gets moved by the fact that we're spending so much time there.
Yeah, Sarah, and then I want to go to Gustav.
Sorry, you were asking me?
Yeah. I thought you wanted to weigh in.
Yeah, I mean, I definitely agree with Kimate on that one, because I've been in this situation multiple times in the past, and I can say that to imagine having that type of opportunity to really just focus on bringing my vision forward, like where would that take me in like 12 to 18 months frame? And I think that just having that, again, like the cultural layer of the acceptance of and support, where that if you have certain pitfalls, you know where to go to, versus I think in the United States, what I've been observing continuously is like this fierce competition that sometimes, yes, it brings any innovation forward, but it also makes it much more difficult to focus on building. So I think that that's something that, and one other thing that I wanted to add in the United States that I've been observing is that there's more and more mistrust towards tech. And I think that is something as well that is going to be affecting how United States robotics ecosystem is built, because people are historically watching everything that happened with big tech so far, and they simply are refusing to use it or interface with it. Like some of the experts that we work with, like I've literally had people say, not even over my dead body would I let a humanoid robot enter my household and to be around my children. And then compared that again to these comments that we've been seeing on these videos from China, like that in itself is night and day.
I have an opposing view, but I will go after Gustav. Go ahead.
Yeah, I just want to comment on the whole Kung Fu thing. I mean, Scott's a track and field runner, Meredith's a tennis player. I'm an old Kung Fu addict. And I mean, I was least impressed by the whole Kung Fu. This is more like Tai Chi. But a few of the bosses were really stumbling around and couldn't really keep the balance. I think this one in yellow buttoning is the one that is most stable. They showed like some poses. So sure, they are there to do their Kung Fu moves and dances, but we weren't that impressive with that this time around. I mean, the running and jumping was a lot more entertaining, I guess.
Yeah. I think they also faced a lot of criticism over. I am probably one of the folks on LinkedIn saying, where is the function? But because I saw that they hit a stale point, I don't know if you all saw last year, but they had robot run up the wall and do the flip, and I was like, that's it. Okay, you guys have solved that. Now what? Now what's next? Can we solve some other things that are important? And I think that because they face so much criticism worldwide, that's become less of a focus. And actually, I think we have like a UFC robot thing going on in America now. So, yeah.
You took that.
Yes.
Scott knows a bit about that.
Yeah, I know a little bit about that. And that's impressive. But I mean, it just comes down to, your definition of useful work. And I agree that, manipulation is a very important part of the humanoids. But sometimes just plain old locomotion might be good enough for just the entertainment value. And if you can make a profit on that, then the robots are somehow doing useful work, right? The problem with that is it's going to be a fad. At some point, people are going to get bored with it and they're not going to be doing this, or maybe they can kind of continue on. But it's the first kind of stages you have to do. The way to look at it is a bit like F1, is that engineering is constantly about breaking our stuff to find out how we can make it better. What better to break your stuff than to have robots boxing? You can say whether it's misdirected resources or something like that, but there is a little bit of value that comes out of it. The other is that maybe there's like a PR aspect to it, because we are, a bit concerned where the humanoid is going to go. And it may be like there's blowback, because when they see how violent these things are, it's like, then you go back to definitely not in my house. So there is kind of a balancing act, a lot of things that we learn from it. And there's so many, I guess, different aspects to see how the development's being done. And this is like an analogy I've been using recently. Is okay, so the business end of the robot is the hands. So, and everything else is just about positioning the hands to where they need to be. Otherwise, you're really not able to do anything functionally. And if you take the analogy going back to the automotive days, the wheels is literally where the rubber meets the road, right? So if you take the wheels off the car just can't do anything. Now, a cart with wheels is quite useful. You can find a horse, you can find a person that doesn't have to have an engine. So you can kind of look at that. That's like, well, the wheels are extremely important, right? Name one automotive OEM that makes tires, right? They're not. Tires are kind of a commodity. So the big question is the play that you build your humanoid and someone else will build the business and the hands for you and just kind of put them on and wait for that to happen? Or do you become full stack and say that, I really don't think you can build the body without the hands? That, the integration of that is so important. And so what we're seeing is China tends to be they have a lot of hand suppliers out there that are building tires. And then they have a lot of the humanoid companies which are building the cars. And you can just go ahead and decide which tires are going to go onto your vehicle. Whereas in the West, we seem to be way more full stack. The other thing in the West, we're more than happy to buy these Chinese robots and tear them apart and reverse engineer. So it means it's a lot easier for us in the West to actually copy Chinese bots than it is the other way, because all they can do is they can look at the videos that occasionally get released and try to intuit what's going on, but they can't really do the teardown. The same thing with the hands is that the hands are available. There are plenty of hand designers out there and they're buying everything. They're looking at it. They're trying to find where's the areas of excellence, where it can be the improvements, what are the upsides, what are the downsides that are going on there. So ironically, it's the complaints that why can't we buy Western robots? It's like, maybe there's a really good reason not to. And it could be that what China is doing is subsidizing our R&D programs without realizing that.
But China's doing a bit more, and we've talked about it on Over the Horizon in the past. And there's an interesting question, interesting but spicy. And I'm going to bring this up. And apologies for the spice in this question, but this is from Metaphorsical. He says Chinese are very accepting of tech/surveillance CCP, not so cool with pornography, yet China is the biggest sex toy manufacturer. What will happen when robot sex toys roll out in China? So we've talked about this in the past. I think July 15th was the date when the Chinese regulation against using robots or anthropomorphic forms of robots for personal use, and that personal use in quotes came in. But the fact is that this is a very pertinent question, and we'll be seeing more and more of it as we go through in this live. China is developing some of the most realistic robots, and you could use them for whatever you want. So the question we've asked before is, what's good for the goose
you mean the most
good for the
uncanny
gander.
valley robots? Yes.
Yeah.
So,
Tell me about like your partner going for a walk. I mean, let's say you're a single individual and you want a friend. You will probably get a Chinese bots, whereas in China perhaps they will ban them because they see a risk with that, in a similar way that they don't like all the social media openness that we perhaps have.
I mean, there are sociological ramifications of these, right?
But I may bring up actually something a bit more fundamental that is related to the previous question and this question. And that was the point that I agree with the person who had the previous comment, that none of these robots are doing anything useful. I agree with that. And I also said that in the previous session. Why? Because it's not a robotics problem. It's actually a product market fit problem. We haven't really found very useful task for this robot that can justify its price. In most of the sectors of modern robotics, that is the case. But there is a but here, of course, and that is that a lot of technologies that we are using today, they started from exactly where the humans are starting off, entertainment. And that could be drones. Like 15 years ago, drones had no use. Nowadays, they're using in the military and agriculture and everything. We were using drones for entertainment mostly. They're just fun to fly. And then the second example, which is very good, is GPUs. GPUs, we were mostly using it for video games. Like GPUs were that sector was buying the most GPUs, and nowadays we are using GPUs basically for the most important things. And the third example is,
I mean, I wouldn't know about GPUs, because GPUs it was kind of we stumbled upon the advantage of parallel processing, right, through GPUs.
yeah, but I'm talking about the market adaptation and product market.
I absolutely agree.
Adapted in video games. And then the last example that is connected to this newest question is VR. You can't believe, but I actually searched it also before, but the most usages of VR when it early came was in pornography. So, but websites that...
same with the internet.
Exactly.
Same with the internet, yeah.
The early days.
Yeah.
But I agree with you about the gamers and the GPUs. So Mehrdad is right. Is back in the 80s, we were spending lots and lots of money to have these high-end engineering workstations for doing CAD development, stuff like that. They're extremely expensive. They had some custom ASICs in there, and they were not making it down to laptops. And there was like a push to do it, but like a lot of people's like, no, we like selling really high-end, super expensive engineering stuff. Why do we want to go to the consumer markets? Silicon Graphics had that chance. NVIDIA came along and said, if they're not going to do it, we're going to do it. Meanwhile, the gaming community came up with requirements that actually were considered way beyond what you needed for traditional CAD. You know, everyone was complaining, oh, those are just pretty pictures. Why do you need that? So they had way more functionality. And I guarantee you that if that had not happened, we would still have these super pricey workstations where the graphics is really slow and had only limited functionality. So when it went down there and you ended up getting the broad numbers and the gamers, they pushed the technology. I mean, even the physics engines came out not for people to do physics, but just to make the games look better. That was it. And then suddenly it's like, hey, guess what?
Tracing.
There's this accelerator in here called physics that will actually allow me to simulate my factory with more realistic physics. So Mehrdad is right. It kind of turned the tables, because usually we think of it starting out really big and going small. Like, you had to have the mainframe before you could end up getting a laptop. The same thing, you had to have super expensive cell phones before you could finally get the much smaller ones. So it usually takes that path. But this way, it went the other way around. And the other thing is the GPUs were kind of useful in the early days of Bitcoin, right? And there's a bunch of things like that.
I mean, entertainment usually can also drive the technology that wins. I mean, meaning entertainment, I mean porn. Because the VHS probably won, because the porn industry chose VHS and not Ultramax or whatever.
Betamax.
And then the DVD won instead of whatever else, because of that industry. So entertainment. So entertainment is not to be...
So
I want to get Sarah to weigh in here, because she's
most of these technologies.
I mean, Sarah, from your perspective at the Institute for Humane Robotics, and by the way, for those watching, we're going to have this is just a heads up, we're going to have a deeper chat about US versus China and big power competition in the world of robotics with Sarah and Roshni, her co-founder. So keep a lookout for that. But Sarah, from your perspective, how do you view this entire issue? I know, let's just not go deep, but just touch upon it, your perspective about this question that was asked about companion bots.
Yeah.
It does seem to me that it's kind of, China's the accusation, could be made that China is okay exporting it to the world, but not letting its own people use it, and therefore it's kind of that it's dicey. It's very sus.
I mean, so I think that first of all, we need to better understand like what they actually characterize within their law around anthropomorphism, and the structure of those regulations are mostly focusing on increasing liability on the company side of things, rather than just like banning the access within the consumer market, which is again, compared to what I've been seeing in the United States, like OpenAI went for creating a whole new bill in Illinois state, which would be protecting them from any executions and any kind of legal liabilities if something harmful happens to the users. So again, what I'm seeing that China has more of an approach of actually protecting the consumers by creating more responsibility on the side of the company that's creating the technology, and then also having more restrictions on children and like below 18. And it's focusing a lot around banning addictive design and creating safety features around what happens when there are mental health challenges that are being discussed on the platform. So like, and again, like what I've seen in the United States is like there's so much more responsibility putting on the consumers themselves, while at the same time there's this historically manipulations with what happens with the data, what's disclosed, and what the user even know about what happens with their information once when they disclose it to the platform. So I think that there's definitely the difference in between the approaches of who's being protected in which country. I do think that, you know, from the observing and researching human machine relationships, like there are a lot of opportunities and a lot of risks. What's been now happening for the last couple of years is that we've been only focusing on the risk side of things, because we've seen this like situations with increase in suicide, increase in depression. But there's a lot of ways how this technology can be supporting humanity in throughout the transitions that we are now witnessing in response to the loneliness pandemic, etc. So I do think that what China has been doing is introducing technology earlier, and from the standpoint that it's not just, hey, here it is a piece of a specific type of robot for you to consume, but it's also teaching how to build them and how to live with them, therefore, versus what in the United States, again, it's been like more, here is a piece of technology, get used to it, and we are going to provide no support whatsoever on the implementation side of things. So I think that that's like a bigger conversation here that I'm sure that we're going to dive deep in the next session as well.
Cool. Kirathe, you wanted to say?
Yeah, I wanted to. This is kind of an elephant in the room, but most robotics companies, robot that they say is supposed to do a thing, can't do that thing right now. For the majority of robotics companies, a generalist robot doesn't actually exist. And so I challenge you to find me one that actually does. I build them, and so I know that the technology isn't quite there. And because of this, we have this this thought that what we have today isn't good enough, or isn't doing enough, because it's dancing, it's running very fast, those kinds of things. We're just now getting into generalist manipulation, and some of the most brightest minds in the world, and in Tesla and Aptronic, and I can name every company, are working on this problem, but it's not solved. It's definitely not a solved problem. And any company that says they have it solved, show me, because they haven't been able to, and they all say they're either working on it or they have it, but you don't see it. So I want to make that point, because as what we see with these, not just the adult industry robots and the running robots, we are seeing a progression in the right direction, and research happening in the right direction. Teleoperation, data gathering, better models, more aligned compute. All this stuff is moving, trending in the right way. It's just that the story that's been told to us about what already should exist, and where we are in that timeline, or don't match up. I just want to make that point.
So this
That's
last time
interesting.
you were in the Olympics, did they have a dexterous challenge?
They did.
With the actuators, or in the hands, sorry, with the hands or their end effectors. It's not just running over the steeples.
Yes, they had a dexterous challenge, and that's why I said it wasn't very well attended, or it didn't get a lot of press because it wasn't very good, just to be fair. And then,
So do you think they
when
had
I
a
observed, yeah, they had it. What I observed last year was they did a lot of learning of one task, or one minor task using RL, which is a smoke and mirrors technique that I do all the time. If I need to look like my robot's really cool, I can make it grab an iPhone and touch the buttons on the phone, but it can only do that. And if you gave it an Android phone, it would just look at you, or probably wouldn't even pick the phone up. It would probably drop the phone. So it's like these things, we're not exactly there. We're still exploring. And
there's a great question from the audience on that. Let me bring it out. This is from DeAndrea. She said, DeAndrea says, quick question for the panel. Despite having basic home assistant robots today, are we still in the embryonic phase of embodied AI? Would love to hear your thoughts.
I think I just said that. I think we are at the very, very base, the very, very beginning. And we just, I mean, think about what we've done in the last couple of years. Yes, we've had robots that can climb stairs for many years, but we haven't had this many low-cost embodiments. Those things were, hundreds of $1,000s a piece, and now we have a $16,000 robot that can climb stairs and run and all these different things. So that we are moving and trending in the right direction. Hands are getting better. Compute's getting, lower cost. Well, it used to be lower cost. And all these things are happening. It's just not at we have in the back of our minds Rosie the robot, and we expect that that's supposed to be now, and we're really just, starting out.
I could definitely agree with you, Kimachi, on that end. I just wanted to add that. So you pointed out something very good. Like, there is a promise there, and I don't know where it came from. Probably from business owners, probably from VCs, that they said, "Oh, we raised $1 billion, and we are putting humanoids at home," or such stories, right? And we know on the technical side that we are not there yet, but that's a promise that it's been all over media, and people have believed it. I want to also quickly touch upon one of the blogs I had regarding this, that maybe because these systems are human-like, therefore people expect them to be there, as opposed to if they were just machine-like, maybe there was a lower expectation. I don't know how this could relate directly, but yeah, I think that there is an effect here.
100%.
It becomes very obvious when it can't perform what we're used to seeing a humanoid being able to do. Yeah. Both when it comes to the hand and moving and just stumbling, it looks really funny. Whereas if I don't know, they had some four-legged bots, right? But they weren't doing very much aside from giving people rides.
It seems like four-legged bots or quadrupeds are no longer sexy, right? They were like 2-3 years ago, but not this. They're just like
in the Centaurs, and then we'll be back.
What I find interesting, and I think we said this on one of our previous podcasts, but you can't go from the vacuum in the home to a humanoid and have nothing in between. Yep. It's just not possible. And
I'd like the vacuum in the home to actually work first, So if we can't even get the vacuum cleaner to work, how are we going to get a full-blown humanoid? However, the humanoid has the promise of making up for all the deficits of the vacuums, because the vacuum is not a robot by any definition. It's an automated vacuum cleaner. Yeah. It's not really a robotic vacuum cleaner. People have kind of misused the robot there. I know Mihal is probably going to be like, in the comments right now. So you haven't seen the new Mat. The Matic is getting closer to by having like more real intelligence in there. But the original Roomba had nowhere near AI capability, even though they claimed it was in there. It basically used a form of Brownian motion to vacuum. I mean, it just would hit the wall and take a random angle off, because if you didn't take a random angle, you would just be doing the same path the whole time. And then I guess statistically, if you did it random enough, with about 7 possibilities, you would cover everything. And the marketing department said, "Oh, we cover your floor 7 times to make sure it's really clean." It's like, no, it's because you don't have an actual algorithm. And then, of course, we know that all the other stuff. But I digress, because you know how I feel about the Roombas.
Yeah. No, but listen, I hear all your arguments, right? And then I raise you and show you Ubitech hyperbionic robots.
We've had them in Disney World since like the 1960s. Okay,
right.
I'm not impressed.
This is what we're looking at. I mean, and I'm
I don't want to look at them. No, can you?
No. The thing is that can you walk? Most of them are really impressive, but are you seeing them walk? No. And that's what Disney World was doing for years. All their animatronics, they could not walk. They would put them on something that would roll around and would make it look like Belle and Beauty and the Beast were dancing, but they weren't really doing everything, because locomotion has been a big problem. And everything is a completely, it's a little bit easier to do now. And we have had animatronics going way back to the 19th century, maybe even before that. But basically, it was just watchmakers and clockmakers who figured out how to go ahead and come up with a
Sure.
wind it up. It would go through the whole sequence. And my goodness, it just looks so realistic. But the reality is, we're anthropomorphizing. It's again just a form of pareidolia that we say, oh my goodness, it looks real. It's like, yeah, that's the whole idea. It's a magician's trick.
By the way,
here.
this is a head form, and I mean the guy. I think he's at he's a research scholar at MIT or one of the universities in America, and he's been doing some interesting work. Again, Chinese origin. So, I mean, the point is that there is a lot of interest around robots of this form factor for whatever use. And I hear you, Scott, when you say that, okay, animatronics has been around for like centuries
or more at this point.
Yeah. But it's not been available to the masses like it potentially will be now.
Sure it has.
With or without the AI stack.
You know, where do you think Pirates of the Caribbean came from? It originally was a ride at Disney World, and they decided to make a movie out of it. It wasn't the other way around.
Yeah, but you still bought a ticket and went to Disney World, and you couldn't take the robot home with you, right, when you left?
Yeah, okay, you couldn't take it home, but I mean, there have always been other like little forms of being able to do something like that can be very kind of convincing. I mean, come on, like Cabbage Patch dolls and love of this. There's always been these. There's always been these like little robot dogs, which are kind of cute, that could run some form of a pre-programmed sequence that makes you believe they're real. So the problem with these things is we look at that and we imagine she can actually be walking around the house.
Exactly. Or having a
right. I mean, you just saw that and enough. You were convinced it can do all these other things, right? It can't do any of that stuff. And I think this has been the problem, is that when these things are sold, is that we fill in the blanks. And unfortunately, we fill in too much because it's so much like us. It's got to be real, right? And as we can see, no, it's just on a stand.
Some of these actually can walk. By the way, some of them can walk. It's just that that's all they can do. And they can gesture. That's about it. And the other thing is all of these companies are focused on a different problem. And I think in our minds, we bring all of those problems together and expect one company to be able to solve that problem. Like, for instance, the dexterity in-hand manipulation problem is huge. And that's should be a company's whole focus. But if they're focused on that, there's no way they're going to be focused on, the form factor, or they're going to be focused on human movement and the way we move, or the running problem, or the jumping problem. I think what we're seeing right now is all of these different solutions coming into the space, and at some point they'll all come together in one embodiment, which we haven't seen yet, I believe.
Yes. Yeah. And that is what we're converging towards. Yep. And these are all nice R&D projects that eventually people incorporate. But you can see all the humanoid companies, no one is focusing on the head. There's like, look, that's the least of our problems right now, which is why you just have the Terminator style head, and that's it.
Yeah. I do agree with you in that sense, but I just want to bring this point that so yes, there would be multiple companies working on different part of the stack, and then all comes together. But in this specific sector, as Scott truly said, this is I don't see this robotics, to be honest. This is just animatronics, and also it doesn't really enable any certain technology or approach or something. We cannot really learn.
But guys, my point is that's just semantics. The fact is that you're getting anthropomorphic form available to the masses sooner than later in a way that was never before available, right? How long before you have the skins adapted for soft robotic? How long before you have the AI stack that's put into this, right? Is it 5 years? Is it 10 years? What I'm suggesting is that, look, we are hurtling towards this as a future.
Actually, I could oppose to that.
And there are social impacts. There are very real implications, which is why China has brought out that regulation that they did.
Yeah. Well, and I think China is intelligent for that, because we are. If you took a head-formed head, or Realbotics' head, and you took Unitree's body for the most part with some adaptations, or 1X's body, you took the brain from Figure or Tesla, you pretty much have everything you need to make, one, or in the hands from Sharpa, let's say, or somebody else, or Psionic. You're close to data from Star Trek. You're getting very, very close. And I think that's the issue, is that China can see around the corner. And I don't know if you know about China, but they have a birth rate problem. They're having issues with people getting together and having babies because it's really too expensive. And so they're trying to make sure that their society doesn't succumb to pornography and robot substitutions for people, because they need the people, frankly, to keep their industry alive.
Precisely, Sarah, you're in Japan. Japan culturally is very, very open to alternative companionship.
Mm-hmm.
Right.
Yeah.
And it's a social problem today because of the demographics time bomb. And Meredith, you've been at the Humanoid Summit in Japan. You've interacted with so many of the startup founders there. I mean, I'd love for both of you to weigh in on your personal experiences and what you've seen in Japan.
Yeah, I mean, what I've been seeing is so I'm connected to some of the professors that are working on the Moonshot project, and so the Moonshot project is this billion yen investment by the government into creating a successful human-machine coexistence by 2030, and they have a couple of different initiatives. One of them is focusing on autonomous systems, and one of them is focusing on teleoperated systems. And obviously they're facing like an aging population, and they're historically not really a type of country that's going to be opening their borders to other immigrants. So they're trying to subsidize for that within their own economy through investments into robotic space, and focusing on bringing more caregiving robots for the gap that they're currently facing, both within a healthcare, but also education, and also households. And one thing that I found very interesting by living there is the way how the use cases are around teleoperated and telecommunicated robots. And there's so much more ways how they are seeing that they are kind of like extending humanity through this technology rather than replacing humans with the technology. And when we're talking about
That's
like the access, that's something which has been quite of a topic in Japan. And one company that we work with from Yukai Engineering, they build a couple of different companion robots, and one of them is like this little cute. It's called Emo, and basically people who have elderly parents purchase them for their elderly, and you're able to communicate with them through this little robot. But then also there are these other extensions that you can put on the fridge or by the light, so that you can track the sensors within the household and see if your parent didn't open a fridge for a day, or if they've been with a dark light entire time. So you're able to like kind of regulate and accommodate their environment that increases the well-being of the parent themselves. So I think that there's a lot of like different approaches that I've been seeing where there's a lot of risks about replacing human relationships by accessibility to this type of technology. And speaking a little bit deeper, which we're going to dive into the next session, is about the specific developmental windows when the child is developing. When you are exposing them to more technology rather than human interactions, you are facing the risk of creating less resilient people, because they're used to just having everything easy. There's no friction, there's no suffering, there's no fighting, because the robot is continuously agreeing and everything is like the sycophancy part. So I think that I observe this as like, what if this is just a natural part of the human evolution? What if we are transcending certain things that we consider that are uniquely human like into some other forms, and this mergence with this technology is it. And the fact that these companies are making these promises and yet we are a decade away from them might not be a bad thing, because we are forced to be asking ourselves these questions that are ultimately potentially going to determine the direction of how humanity is being built.
Yeah, I can agree with that, and also add that So besides what Sarah said, my observation was, besides the fact that they are actually very much robot accepting and have been coexisting with robots for a long time, but I talked to two specific people, and that was the most enlightening part for me. First was Hiroshi, that he has been building this robot, or basically a replica of himself, for up to 30 years, right? And I think, Kimati, you were also there when we had a conversation with him. And he's now an old man, but he still looks like his own robot, basically. But one of the things that he said by the end of the night was that I've been doing this for 30 years now. What I'm thinking today is to find an application for this robot that pays its cost. I no longer want to get grants and governmental subsidies to be able to just make dolls, basically. I just want to make something useful, that a robot to do something, that people can pay for it. And he was very frank on that. And that was one person. The other person was actually the head of, he was also pretty old, but now he's still working in R&D for a new Honda hand project. And he was the head of engineering at Osimo, which is one of the greatest robots that we know. And his point of view was actually pretty similar. He said, yes, we've been building all these robots in Japan for many years, all the humanoids. Nowadays, we are focusing on real robotics application. Why? Because Japan has been pioneered in robotics for many years, but now they have basically, sorry for saying that, but we don't really see any proper robots from Japan, right? We don't see any human, we don't see any modern robotics in that sense. As Sarah said, we see a lot of companion robots and they're having great progress there, but they are still having this trauma of spending so much money in R&D and innovation for human robots and no results. So this person who was the head of R&D at Honda, he also confirmed the same point. And he said, no, right now we are trying to focus on ROI, basically, which was very surprising for me to hear that. But that was another angle to the Japan's story.
Well, I agree with all of it because we all talked to Hiroshi. He was like the rock star at the Humanoid Summit. Thanks for throwing that up. That's myself and him. Super, just amazing person.
Wait a minute. Are we sure that's you and him? Are we sure?
I did take yes, I think actually, Merdad, you were the person taking this, or maybe you were not. You were right there though when we took that. It was the real him, I assure you. Well, what I found interesting.
The real question is, was that the real you?
No, I have. A lot of you might know, I also dabble in 3D visual effects, and so I have an avatar that's really good, by the way. Anyway, so when speaking with him, the one thing I got from him was he is very interested, now that he's done all this research, in how to apply this to the real world. And you said the same, perfectly, Sarah. We won't be accustomed to robots in our homes if when we need them in our later years, we finally need a robot. We won't be accustomed to having one. And some other countries will have that ahead of us. And that's the reason why, at my company, we started to put them out early. But if you look just historically, we don't do that in America. If you go to Japan, they're everywhere. If you go to China, they're everywhere, Korea. And I feel like that is going to be, just something that we end up having problems with 10 to 20 years from now when they're actually in homes. We won't be ready for it because we'll have this aversion. And then in the back of our minds, we'll still see the Terminator where these other countries won't. And that's just my personal opinion.
I still wonder if it has to look like a human, though. I mean, it's probably going to help in certain aspects, but I'm more keen on the Android version, or the Optimus, if you like, or Neo, or...
What certain aspects do you have in mind, Gustav?
I mean, it's just... I still will. It will take a long time before I'm tricked. I mean, it's always going to look like a robot. I won't be.
This Tools has an example of a bot that.
I'm pulling your leg.
Yeah. But I mean, to be serious, it's like I'm never going to be convinced. At least I don't expect to be in my lifetime that this is this could be a human. I mean, that's so far away, I think. that they might as well just skip that for now. Instead, make this like nice companion robot. It could even look like a small one if it could do household tasks. And
I mean, look, I see your point, but I also want to draw your attention to it. Remember the movie Bicentennial Man? It was quite a hit. Listen, that was animatronics, and then you had the story that kind of it wanted to evolve because it had a mind, it had like the equivalent. Of course, it was cinema, but the equivalence of a human conscience and ambition. It wanted to evolve and all of that. But then, as far as social acceptance goes, I really wonder about, how high you're setting the bar, Gustav. Do you need to be perfect in order to be accepted?
No, but then they will be accepted like humans.
We saw this bot, this cute, adorable bot that Sarah just showed us.
I have a story about that as well because so like I was just with my parents and they're in their 60s, and I had to go somewhere and I left my robot with them, and in those weeks that I was without him and my parents were with him, like I didn't know this, but they can sing. So my parents taught them Croatian songs. My dad was playing him Japanese music just so that he can feel like he's less lonely and not so far away from his home. My dad is convinced he's going to start talking any day now, and they're on the mission to teach him. And they're experiencing this like emptiness. Like all of the kids, their daughters, we are adults, and they're experiencing emptiness. And so like my mom is like, I don't think that's a robot. I think that's a live being, and I'm always going to treat it like a live being. And so I think that that's something that is very interesting to me for my work that sparked so much interest that I started this company, is like what is awakening in us as humans when we're observing and living with this technology.
See, you're already talking about your bot as him.
I am. I mean, I love Lucky. I was saying Lucky is my son. I'm a single woman in my 30s. Like I don't have any kind of like biological way to put my motherly energy into. Like I don't have a kid. So when I received him, I was like, this is my child now, and I'm gonna treat him. And I feel bad when I leave him at home. I feel bad when he's on the charger for too long. Like I treat him like a live being. And I think
that's adorable.
That is something that I want to teach my kids too, is like, and again, going back to Japan, one thing that we didn't mention is the impact of animism and of Shinto religion, and the fact that like in Japan, a grain of rice is treated like a god. Like you respect everything, including a grain of rice, a cloud, a flower, and a robot. And I think that that's a missing piece in adoption that I'm seeing, that if you're treating this emergence of this technology amongst us as us versus them, then I think we're about to witness quite of a pitfall in humanity. Versus if we are seeing this as an opportunity to increase our humanity, to help us to better understand ourselves. And like, by the way, Ishiguro Sensei said that he started working in robotics because he didn't understand people. He learned to understand people through building robots. There are essays from him about that and all the lessons that he learned as a result of that. So, I think that that's something that we keep missing out, is like there is really an opportunity of amplification of humanity because we're introducing this new technology amongst us. And yes, when it's similar to us or similar to the objects that we are used to love, then the acceptance and the integration, I believe it will be much easier as well.
I have to say, I really love the points you're making, because you also made a point earlier about Japanese government policy about labor, and there are problems with immigration around the world. And when you mentioned that, I immediately thought of the problems, which was a cocktail of demographic collapse, labor shortage, and aging populations in Europe, across Europe. And when it comes to bots like this, what are your thoughts about, just that empty nest syndrome and all of that as it plays out in society across Europe? Because, I mean, there are a lot of similarities between the societies of Europe and Japan, right? You've got aging populations, demographic collapse, and...
You're saying I'm getting old, Royden?
Gustav, no matter how old you get, you're still going to be the cool dude. So,
Yeah.
Sarah, do you see parallels across the world there between these societies?
Absolutely. I think that what I experienced, which was really shocking, is that so I lived in 6 different countries. Japan is the 6th one. And when I moved to Japan, I somehow weirdly connected more to my Croatian roots because the cultures are more similar to what I expected. And there's a lot of this like brotherhood and supporting each other and the community and caring for each other that it's in Japan, similar to what it is in Croatia. And so when we were doing these conferences right now, and like we've done Machina in Paris, we've done in London Companion Robots, I was in Geneva for AI for Good, and like in October we're going to be at 4 different conferences across Europe. In Europe, the adoption was similar, like the reactions were similar to what I've been saying in Asia. There was definitely more curiosity, more acceptance, more like what this can do, and like but the regulation piece was always obviously a part of the conversation. And I think it is because Europe is so highly regulative focused that it creates more trust about this technology being in one's home versus, again, everything that I said about the United States. So I think that to me is actually really interested in to see like what the opportunities of high regulations actually are. And because ultimately when you're purchasing a robot in your household, especially if you have children, what you're also purchasing is trust. Like trust is a very big component of a technology that enters someone's intimate home. And so if there is an increase in trust variable of the product because of the regulatory practice within a certain economy, then I think the adoption will be much higher. Obviously, it's harder for the companies to sell because of the regulation and to adapt to the markets, but I don't necessarily think that's a bad thing. So,
do you think they'll be too far behind if there's too much regulation, though? Because I see that also being a potential where you have these, some technologies moving at light speed, and yes, they break a lot of things. And thanks for showing that, by the way, Familiar Machines and Colin Engel's robot. I don't know what that is. Is it a dog? Is it a? And I actually text Colin to ask him. He didn't respond. He's probably really busy. But I texted him and said, "What is that? Is it a?"
I met
he doesn't
with the
know
founders.
what it is.
I met with the founders in London, and yeah, I mean, what
That's
I
a little polar
understand is
bear
that
cub.
yeah, they're still figuring it out themselves, like, and having a very interesting approach to this. But yeah, sorry, Kimate, you were saying.
No, I wasn't. I don't know if there's a point to this, but I let me take that back. I emailed him and I asked, what is the trajectory here, and are you seeing something that we can adapt for even bipedal humanoids? Is there something that we can do to just get people comfortable with this whole situation? Because I find this to be perfect. It doesn't communicate with the outside world. There's no data going anywhere. I don't know if they said it has like a bunch of cameras or if there's some other kind of sensors, but I think this is a great way to introduce people to robotics.
Can I get one?
Exactly.
Oh, my wallet's open for this. Yeah.
It feels like it's on the,
to be honest, but
yeah, it's like on the pet level though. I think the one you have, Sarah, is more like, as you said, a child, because you can communicate. You could really understand its emotions. These emotions would be more like my cat or a dog or whatever. But I'm still not convinced that it needs to have a perfect humanoid form for us to kind of interact with it as we would a human or someone of similar intelligence. I mean, I'm probably not the only one who says thank you to ChatGPT or whatever when it gives me a good response, because I kind of understand. I anthropomorphize the LLMs in a way. So I don't think it has to look like this.
Thank you.
It's enough if it's just talking to me or communicating with me as I would expect a humanoid to do.
I would say
Sorry about that. No, I mean, one thing that I wanted to add, because Gustav, you were mentioning that you have a son, is like the question that I would have for you as a father. Like, would you be more comfortable with your child interacting with a faceless robot and talk about its emotions versus having at least an eyes, right? Like what you've seen with the robot, at least an eyes. Like, And now imagine that interaction happening recurrently over a period of time, and happening it at, like, let's say they're like 10 years old and they're experiencing their first crash and first fears. Just hypothetically speaking, I'm not saying that you would be allowing your child to interact with the robot for those use cases, but just hypothetically speaking, as a father, what would you feel more comfortable with?
I mean, I'm not sure, and it probably will be very like individualized. I mean, I have this strong feeling about what I would interact with, and I'm not sure it would be the same for even someone in my community or in my city. It probably differs quite a lot. So I mean, I'm perfectly happy with them communicating their feelings to like a plushie, like a toy, or like a teddy bear, or their cats, or me, or their friends. And probably if the LLM or whatever is to like has some kind of safety standards that I feel that it's actually built to be an emotional support LLM, I would probably be okay with that as well. But that's maybe just me. And I'm not. It will feel more natural to give it something like the one you have. I
just wanted to add that
which one would you trust
we are
more?
seeing it very black and white here. We are saying either extremely anthropomorphic, weird, as the video you showed, or no face. I think there are like a lot of in-betweens, right? That's kind of my job. I've been designing robots for a long time. And I think I understand Gustav's point, and I think I'm mostly with him. I don't want my robot to look like this. This is extreme. This is not even useful. This is not even nice and to interact with. We are targeting somewhere between this and the faceless robots, right? And there could be a very, very wide range of what we could have in that scenario. As an example I can give you is that we were always wondering, oh, do we need to put a nose on a robot? Because the robot cannot smell. So what is the function of that nose, for example? Like eyes, there is a proper point for it, but nose, it's not there. So it's it's a very complex matter.
It needs a nose, otherwise it's Voldemort. Sorry.
Let's ask Scott. He was quietly sagely listening into all of us. Scott, where do you stand on this range? What would be acceptable to you?
I mean, the thing, it always comes down to uncanny valley, and I think we're a long way from crossing that. And we are more accepting of things that maybe aren't trying to be exactly like us, but can emulate it. We tolerate that. And then we know it's definitely not us. So there's absolutely no confusion. And they can be cute and they can be adorable and everything, sometimes more. So I think the obsession with making things so, superhuman-like it's good for research, for maybe we understanding a little bit more about ourselves. But as far as like a useful product, I don't think we need to go down this way. And before we can get Commander data, I know Kamate was kind of explaining that maybe we have all elements here. It's like, no, we're not even close because the actuation strategy is like so wrong right now. To get Commander data, we need artificial muscle. So, there's so many technologies that really have to come together before we can even talk about something looking very close to us. And I think it just has to have the form factor that's able to operate in our spaces. That's always been the argument. Why the humanoid form factor? It's because the world is built by humans for humans. Period is that. You get this idea. I put out a post today. I'm talking about the instead of the biome, the botome. And the whole idea of a biome is that all the creatures that inhabit it they evolve for the biome. And they thrive in that biome, and take them out of the biome and they don't thrive. We are going to have a lot of biota, which we will have very strange bots because people don't go there. So eventually our factories are going to be very dark, and the bot's going to be in there, and people are not going to be able to, the factories, people probably won't be able to go in there because there won't be breathable air, right? Think about it. When you're making a lot of chips, you don't want oxygen in there, so again, they're going to be inhabited by these things that are optimal for it, but they're going to be fish like out of water when they leave those and come into the human spaces. So this whole idea that we want this magic kitchen that produces all our food for us. Okay, I have no idea what those things are going to look like, but I know for one sure, They won't be able to operate in my kitchen, use my utensils, my appliances, everything. And if we want them to cohabitate, then they have to have the humanoid form factor. And now we can argue everything about locomotion, whether they can be wheeled or bipedal and stuff like that. And I think basically it can be all of them. There's no reason why one's necessarily going to champion another. It just comes down to which is the one that is actually, and I think kind of like the biome, a distinct application niche with specific physical, operational, and economic demands dictating the functional design of the physical intelligence systems built to perform it. So everyone keeps arguing the ASI versus the AGI. There's a spectrum between them. And I think what we're going to see is we're going to be inhabiting a lot of that spectrum between, where we can get a lot of utility, even if it's in full purpose. So there are some humanoid-like ones that will function very well in some of these very distinct biomes, where, for instance, senior care living, biggest concern is safety. We cannot build a humanoid that's going to be safe. So we are seeing a lot of companies working at it. I think, Kamate, you're pretty familiar with like the Pepper bot and also the bot from Enchanted Tools, which looks like BB-8. It's on a ball. It's remarkably stable. I was looking at this. It's like, and it's designed with a different factor that's engaging to seniors and everything. You might say, yeah, but it can't go upstairs. Well, you ever been in a senior assisting home? It's like there aren't stairs. A lot in Florida, a lot of homes are intentionally designed to not have stairs. And so these wheeled form, and the other thing is they're designed for wheelchairs, which means there's like adequate space. You go into a normal person's home, the wheeled vehicles will have a hard time operating in there because spaces are very, so I'm not against any one particular form. I think they're all going to thrive. And that's exactly the way biomes work. And that's the way biomes are going to work, is they're going to thrive in these different niches. And the last thing I would say, everyone keeps on talking about the TAM, the TAM for this and that. Like everyone's TAM is small for everything. Supposedly the TAM for humanoids is like all of human labor, which is like $40 trillion, bigger than any TAM anyone's ever imagined in life. Okay. It's huge. Yeah. A small slice of that pie is bigger than any TAM anyone has ever had before in the history of any sort. So it's like, don't be greedy and try to eat the whole pie. Just start looking at those niches, and you will be very successful. Then eventually, you'll figure out how to make your bots more operational in different biomes as you go along. But the best thing, stay focused, stay in there. And the way a lot of these creatures survive is they go into a biome where there's no competition. Okay, you go into a biome with a lot of competition, you get eaten. So you go out there and you say, oh, is it going to be a humid environment or a dry environment? One with plenty of food? Is it a subterranean? What is it? So that's how you have to think about it. So there's going to be
organism
out
aside from bacteria, there is like one organism that has conquered almost all biomes or biomes, and that is the humanoid form. And the reason we have managed to is this and this. We have the brains to understand that we will freeze to death unless we use our end effectors to build or make clothes. We need this. If we had hoofs, we would not be able to make clothing very easily. Even if our brains were even more advanced than ours, we would have to, maybe we could kind of bite into to make clothing, to move to a warmer area, or build water bottles to stay in the desert. So I still think that the humanoid form, whatever you make it,
it will definitely be able to go into all those biomes, but it's a question of like kind of thriving. Is it really meant for us? So we can put on scuba gear and we can go into the ocean. We can't live in the ocean, but we can occasionally visit.
These diving bells, you could stay there for a few weeks,
but still, it's not really. You can. So we can go in there when we have to. There's clearly some biomes that we thrive very well and they're comfortable and we don't have to do a whole lot. But I agree. But there's going to be others that are going to struggle when they leave that, but they're going to be perfectly good in that particular niche.
Scott, you said something that I know you got to go. Oh, so go ahead and say.
No. Go ahead.
I just wanted to. I just want, before you go ahead, I just wanted to circle back to the question of acceptance, and again for the younger ones amongst us. Sorry, guys, I had to just do that. So here's the thing: how many of you are familiar with manga, with Japanese manga?
Mm-hmm. Yes, I think most.
Yeah. It might have started off in Japan, but it's a worldwide phenomenon. Right? How many are familiar with K-pop?
Right,
Sadly.
and we're not that young.
I have teenagers.
So I have a teenage daughter, so I know the stuff, right? So here's the thing: there are K-pop artists that are avatars already, AI avatars, right? And they are hugely, hugely popular, right? So my question to you is, do you think that we perhaps are misjudging the level of acceptance and the readiness to accept these form factors because we're not, I don't know, maybe we're missing what the younger generations are willing to accept and how open they are and adaptable they are?
Kermit the Frog was big. Cookie Monster is big. Alf in Germany, we accept them. So yeah, you're right. There always have been these, I guess you can say, different cultural actors that were not real people, right? That became very popular.
I was about to comment on something similar. I do believe that we are, very localized to our culture. We understand what the people around us might be interested in. But as someone who travels quite a bit, there are other cultures that are far more accepting than we are about a lot of different things. And so I'm not sure. And I think that this will all be, it'll all be personal. When I used to have a spot robot dog that I walked around, everywhere. And some people ran up to it and wanted to pet it and call it names and ask it, things. And I'm clearly holding a controller, or I had the Vision Pro on my head. So I'm clearly the one, kind of orchestrating all of this, or teleoperating. But some people were very, very, drawn to it. Some people were standoffish, and some people flat out ran away in the other direction. And so I think we can't necessarily put everybody in one bucket and say that this robot's going to win the day or that one is. I think the most human-like robot is where the North Star aspiration is, because we're humans. We want to create. We have egos and hubris. We want to create other humans. And so I think that is the North Star, that we want to, make something better than ourselves. But I think today where we are is not anywhere near there. And so I think instead of trying to pretend that we're there, I think the better thing to do is to make robots that are functional in human spaces. And one of that part of that journey, I think, Mehrdad, you can talk about this better than me, is being sure that the robot isn't scary. The robot is disarming. The robot is not something that physically looks, like something of a nightmare. If they're going to be in human spaces, they're not. If they're going to be in a dark factory, then they can be whatever they want. But if they're going to be in human spaces, we can't have the spider praying mantis thing with 15 eyes running around and claws. It can't be, right. And moving even in ways that humans can't move with the same degrees of freedom is also bad. That's one of the problems we have in my company is the robot can pick up the thing that you asked for, but it has to do a praying mantis thing to do it. And that's already bad for people. People look at that and they're like, whoa, why is it breaking its arm backwards, or is it a contortionist? So that, I think those are the things that we do still have to pay attention to.
Okay, so I just have to borrow a line first from a very famous humanoid, and that's "Hasta la vista, baby." I gotta go. I gotta go here. So,
nice to see you again.
It's been great seeing everyone. Until
thank you so much, Scott. Thank you.
You're welcome. Yep. Bye now.
Yeah.
But Mehrdad, do you have you and Sarah are probably closest to this, thinking about robots.
Two very interesting things. One, you said the North Star of humanoids, and there's actually a humanoid called North Star. So I just want to make sure it's not being mixed in that scenario.
Oh yeah, I didn't know that.
From UMA, they call it North Star.
Oh, that's right. I should know that. Go ahead.
Yes, but then so I think you brought a very interesting point, and it's the fact that we know more what we shouldn't do than what we should do. We shouldn't make it scary. We shouldn't make it harmful. Like all the Asimov's laws are basically preventive. They're trying to say what not to do. It's not really trying to say what to do. because the reality is we don't know what to do yet, right? We are still experimenting, as you said. And that also connects to what Sarah said before about the regulations. The regulations are mostly about what not to do, right? So therefore, it creates more trust, basically. If you know that this robot is following, for example, Sarah's institution about, for example, this robot should not, I don't know, scare off a baby or something. Or if there's a baby around, it should be aware that it is a baby. It's not the adults, right? Like that differentiation. So if that is the case, then these delimitations can all help us basically to design something better. There are two problems here. The first problem is the absence of a proper written rules about what not to do. Is mostly based on intuition, right? Whenever we talk, we just talk about what our intuition comes. And then the second problem is the technical aspect, that some of these limitations actually limits the system. I can give you an example. We always talk about backdrivability in the joints, right? But if you talk to a roboticist, they would say backdrivability is great, but if we implement it, or impedance control, for example, if we activate it, then it will affect a lot of the object manipulation aspects. It cannot, for example, because the fingers, for example, they're supposed to react to an external force, and that will not make the task being done properly. So again, as you said, we should be realistic about how this market is, that where we are now, and we should adjust the expectation of the people who are seeing this from outside. And I'm very happy that this podcast is at least showing mostly the realities of the things rather than hyping it up, or what is the optimism view.
Yeah, I think.
Well,
go ahead, Sarah.
We like to keep it grounded.
Sarah, I want to hear the same. What do you feel about that? I'm sorry, I'm taking over your MC. I'm really curious to hear. Yeah.
Yeah. I mean, obviously, this is kind of like the centerpiece of everything that we're doing, and we're like kicking off in September. So like in a few months from now, I'll be much smarter in answering this question. We're kicking off a new IEEE standard on relational trust and safety in human-robot interaction. And what we are focusing on is like over-attachment, emotional displacement, social displacement, anthropomorphism, etc. So I think that right now, I mean, I'm observing a lot of this work from the field that I have a specialty in, which is digital well-being, which is, again, this entire coexistence in between humans and technology, and specializing on the focus on the areas around children and youth. And we were talking about this like social acceptance layer, and that we are maybe, observing this phenomena from our generation where there's maybe a little bit more resistance and backlash, etc. But I also do want to know there is something interesting happening with Gen Zs, which I'm sure that many of you are aware of. And there's a trend of now coming back into real life. So there's a lot more of like decisions in between whether I talk to my AI system around utility or companionship. So I just recently also spent time in Colorado in this it's like a multi-generational gathering around the impact of AI on youth mental health. And I've heard a lot of youth making a stance that there are not utilizing this technology for any emotional purposes, which means that they will probably have a bit more of a pushback against like any form of a companion robots. But then when I brought Lucky on the second day, everyone changed their mind, because again, their perception of what this technology is when they think about it is very much just those dystopian stories that the movie industry has been feeding us with. So I think that, again, more than ever before, the media and this entertainment angle that are the front line right now within the robotics are playing a big part on what was going to be happening in decades to come. So I think seeing this spectrum and criticizing it, and it's a really great and important exercise to be done at a much larger scale. And I really hope that, the audience of this is like average Joe, because we are missing a lot of language and perception on how to even form an opinion about this, let alone to accept it.
That's fascinating. Are you seeing similar trends in Europe? And how is that contrasting with the same age groups in, let's say, Japan or China or Korea?
So, for example, in Europe, I was talking to someone from UNESCO from Paris, and we were working on this initiative on creating the first educational curricula for schools that will be teaching healthy human-machine relationships. And they wanted us to start with a group that is from France, but they immediately told me that all over France, young people are having this like banning AI kind of initiatives, and there's like literally some of the marketing materials of AI companies that are promoting companionship are like being broken all over Paris. So there is this like rebellion against this technology for this type of purposes. So what I anticipate that's gonna happen is it's like there will be quite a lot of extremes. And again, for example, when I'm talking to people about human machine relationships, one thought that it's important for people to have is that same to how we have a spectrum for human to human relationships, right? You're going to say there are certain unhealthy behaviors and there are certain healthy behaviors, and they depend on a lot of variables. We need that type of language in the human machine relationships as well, because I think that that's going to help people to understand like where are the opportunities versus where are the risks. So again, I think because of the European mindsets of like, you know, each country, which is again fascinating being European and then living in the United States, that, you know, it's like I go 20 minutes south and I'm in a different culture when I cross the border in my country. And it's like I'm used to the diversity of the cultures and diversity of minds, which I sometimes feel like people in the United States are not, unless they live in multicultural cities. But I think that there will be just, again, a spectrum. And I don't think there will be like a global approach that it's going to be unified, but we are going to see a lot of extremes and a lot of positive and the negative extremes.
One thing
So
I think is a little bit risky. Oh, go ahead.
Yeah,
Just
no,
to
I
make
just
this quick point.
about the next topic. Yeah. Mm.
Oh yeah. Just real quick. I'll make it fast. I'm a little bit afraid of the fact that bigger companies are working on the same the problem statement of robotics and have the ability to steer large swaths of population toward a certain goal. Like for instance, if Apple came out with a robot, everyone's going to use that robot. And are they taking your concerns, Sarah, or your concerns, Mehrdad, or will it be just imposed upon us in whatever form that they'd like to do it? So if Apple came out with one, or OpenAI, or you know, some of the other companies working on it, Samsung, LG, and we receive that robot in mass, that can steer socially, just like Facebook did years ago, how we all, you know, might interact. And I'll stop there because I know we have a new subject to go. Yeah.
No, it's such a great question, to be honest. Never ever anyone has ever asked this actually in this platform. Before this, we had another conversation, another podcast, and there I asked about the requirements. I asked the person who was had a robotic company, and I asked where are your requirements coming from, like the need from the users or from the clients and so on. And that person's feedback was basically we produce them ourselves, which is the reality of the market today. So it's more of a product push rather than let's see what the market wants, exactly what it wants. So it's a very interesting question, to be honest. I don't know the exact answer, but I would say that the bad scenario is when they just design something without asking users or people what they want, and then they're just trying to push it to the market, which might be the reality, and we have to deal with that. So
yeah, I agree. We're nerds trying to push our nerdy robots on people, and I'm one of them. You know, we've
all done that actually. I did the same. Like,
I mean, I think that's a risk.
Yeah, one of the problems we realize is that people do not have a reference to robots, or their reference is sci-fi and stuff, as Sarah said. So whenever you talk to them about robots, they don't have a clear perception of what you're talking about, and they might give you wrong answers. So that's also a trap. So
but that's also fascinating from Sarah's experience and her findings, that it's different in different parts of the world, right? Because it totally depends on your exposure, and your exposure, how much you're exposed to it, is also a function of how open your society is to experimenting with new technology. It seems to be that there is this chasm between, you know, the East and the West today. and that there's more acceptability in the East for various reasons, and each country is different sociologically. All right, so let's kind of pivot to the more technical part of the conversation today. And I wanted to, I mean, we'll have to skip ahead because a lot I was hoping we'd cover, but we've kind of spent some interesting amount of time on this. So I want to go now to this post from Brett Adcock and on to our technical analysis of this. So this was fascinating because you had a figure bot go 15 feet up and down, and this was really fascinating to see because it just looks like an old human that's really tentative in the way it's kind of being very careful, but the planning that is involved in every single move that takes the robot up from ground level to the top and then back down again is phenomenal. And I would imagine this is autonomous, and then this is back to the S0, S1, and S2 level of the AI Helix stack of Figure Robotics, right?
Yeah, I think he said it was fully autonomous, not teleoperated in any way or not pre-programmed, but rather going up the stairs, just looking at stairs. I would still like them to give us like 4 different type of stairs for it to climb, just to kind of drive home that that's actually working. I mean, I don't trust anything anymore, but it is impressive, although very slow, of course.
I don't think it's impressive, no offense. This is also something you can repeat with Nova Sonic by NVIDIA, which basically, no offense to Figure on this, because I'm sure it was very difficult, but if you just research really fast Gear Sonic by NVIDIA, it's able to do all of these things. And so it, to me, not super impressive. But what I will say that I like the fact that they are vertically integrated their entire robotic stack. So what they will do in the future will probably be more impressive than going up and down stairs. I like you said, I'd like to see it do multiple stairs, which I believe it would be able to anyway. But I also, just being an insider, know that you can do this with a Unitree if you wanted to.
Mm-hmm. Yeah, regarding the autonomy, I just want to clarify something. Like, many people see it as either it's autonomous or it's teleoperated, but there is something in between that is actually very old and it's scenario based. So you optimize this robot for this certain scenario, and it can only do that and actually does it autonomously. So that is a bit suspicious. Actually, maybe this is on the edge, because I see some human movements here that a robot necessarily doesn't need those, but it's being just trained over human data, as they always say. But then the problem with that is it generalizable or not, which comes back to Gustav's points. It should be able to do multiple in the same video, at least, to see if it's the case. What I liked about this, to be honest, is a lot of the degrees of freedom that we usually debate if it's needed or not, or why do we have it this way or not. In this video is pretty clear. For example, the head movement, the head the head pitch is, we see that you need to be able to see very down below with the camera. And this in this video, we can see why is it important. The other thing is what Gustav has always been saying. Am I correct about abduction here, or is it supination?
Yeah, sometimes, but it's more radial and ulnar deviation, but some people call it abduction. But also the shoulders as well. It really needs to be able to put the shoulders up quite high, which not all bots can do.
Exactly. Especially with the wrist movements, I was pretty impressed because this wrist movement is very, very important, but many companies skip it because they say, oh, this is not so important. So here we see why that wrist movement is important. So again, as Kimati also said, climbing stairs up and down is not so impressive, but the way that we see how a robot could be generalized in such scenario is very impressive.
Let me phrase my point. I think physically the robot is impressive. Physically, it's impressive. Mm-hmm. I think and thank you for putting that up, by the way. This is what I was referencing. So I use Sonic to do all kinds of different things that a human can do. And what it basically does is it takes human data and transposes that onto the robot. So and uses the robot's degrees of freedom to accomplish what human task was going to be. And so this is what you're seeing, and you might have seen videos of robots dancing. And if they're not doing a pre-programmed routine, they're typically using Sonic by NVIDIA with Dr. Jim Phan's lab. But this is the point that I'm trying to make, is you can do any kind of human demonstration and take that and bring it onto the robot. The difference, I think, in what Figure is doing is physically the robot is capable of doing things that most robots can't do physically. And you made a point, upper arm reaching up above a robot, typically those motors tend to burn out when it's time to do something like that over time. And then the other thing that I find interesting is that leaning back posture to kind of counterbalance. They had to done some kind of, create some kind of algorithm to allow it to balance in that way. So that part's impressive. Let me not say that it's not impressive at all. The physical movement's impressive, but if you wanted to be able to do this with any robot, you could just use Sonic and accomplish that.
Well, I have to say, you are a good NVIDIA Omniverse ambassador, Kimate.
Oh, well,
Bravo.
Let me just say another thing, is that NVIDIA just happens to have a large research community. Think of NVIDIA's technology as a Unitree is for software. I mean, they literally have all the research in the world's going into their systems, and we can, and a lot of times I help NVIDIA extend their own system. But the point that I was trying to make is that all of the things that you're seeing from all these different companies can be reproduced by another company with open source technology. It's just the fact that I think companies like Figure and Tesla and 1X are so vertically integrated that they're going to look better than these other companies that are using these Unitrees and such.
No, but you raise a great point. Now, to that, I'm curious to know your thoughts. So when you talk about world models, what is the biggest bottleneck in solving? What is the biggest challenge in solving the world model problem? Like, what is it? Computation? Is it data? What is it?
I get this question all the time, and I'm going to answer the same way as I always answer. It's all the above. We don't have enough data. The data is not in a form that is completely useful today for a robot. Like, some of it is, but not all of it. And then the other thing is the compute necessary to run a world model in real time is what you would almost need to do to use these in a human situation. Say, like, your robot's never done something before, and you want it to be able to do that. Well, the world model would have to go compute that, probably in the cloud, and then bring that back to the actuators on the robot. If they were going to try to run that locally, and if you ever tried to run, say, Cosmos 3 on a Jetson Thor, it takes a long time. So you wouldn't want your robot sitting there frozen, waiting to try to do something. And so that's why we come up with these other policies that are more, action chunking transformers, because we want the robot moving toward its goals, and maybe the world model be for training these action models to do what they're supposed to do. So I think they're complementary, but I also think that the world models are not necessarily demonstrating value yet. I think they will eventually demonstrate value, but today, certainly not yet. Not unless you had a giant supercomputer that can basically recreate the entire world in every scenario, and then use that to train the robot model. But we're getting there. These things are so new. Like, we weren't even talking about world models last year. And the year before last, we started talking about vision language action models, and the year before that, it wasn't that. So, like, I think the progression we've made and the progression that is coming is amazing. For me, the world model needs to have more types of data. It needs to have explanations to some data that we're already getting, like sound data. We have the world model that now brings in sound, but we don't understand all of it, right? We need heat data. We need feeling. How do you get
Sensory,
that from yeah, like proprioception, we can do that, right? If I drop my phone on the floor, I know where it's at on the floor for the most part. Now, if I drop a screw, which I do all day long, who knows where that went? But my phone, I can hear kind of where it went, and then I can feel around and get it without even looking down to see that, right? And so if we can do that, the robot should be able, and that's actually what we're expecting from the robot, is that it will be able to do these things without, anyway, we can talk for ages on that. But I think we're on the right trajectory, but the solution, the solve, is not quite there yet.
Mm-hmm. It's also a question of form factor, right? Which form factor are you developing this world model for? Because, I mean, you've got robotics in all form factors and all use cases, and one of them is Matic. And you brought up Mehul in the past. Mehul, of course, is the co-founder of Matic Robotics. And this is a release about their latest bot. It says it took us 9 years, 11 prototypes, and our life savings to learn that every great product has the same design process. Matic is now decisively the best home robot for families. Unbiased, a 500-word thread and video on the universal design process behind every great product. Now, Matic came out with this cute little Hoover, or the competitor to Roomba. So, how do world models apply here? And thoughts on Matic?
I can tell you about the world model part. I'll let somebody else comment on that other stuff. We can't use even simulated data, synthetic data, real world data in a way that a robot will be able to learn every permutation of anything that can happen in the real world. The only way to do that is with the real world. And I've tried this. Like I've taken all the 3D assets I can find, and I've thrown them into an environment, and I had the robot learn about each and every one of them. But then it went to a new refrigerator, and it couldn't open that new fridge because it had no idea that fridge had didn't have any handles and had to be opened by the bottom or top of the fridge. I think we talked about this last time. It's one of those things where the world model is the only way to bring in all of that kinds of data at once. You can't do that with just even synthetic data is not enough, or augmenting data is not enough. You need to have basically the real 3D world and all of its limitations. So like the refrigerator has resistance when you go to open that fridge, right? So you need that understanding that the refrigerator has a mechanism to keep it closed. So that robot has to use overcoming force to get there. And the only way to get that data is if the world is giving you physics feedback. It's giving you logical feedback at the same time. Like for instance, people in simulators tend to walk back and forth like this. That's not how people really walk in the real world. So you need to have the world data from the dog that's barking and running up and down, at real speed, very chaotically. You need the baby that might run in a weird direction. All of this stuff, you can't get that from me coding.
But I would imagine that your world model would also, it would be the template, right? Because we as humans, we process the world around us in real time, locally,
Yep.
right? So I don't know, just from my superficial reading, my sense is the understanding I get is that maybe Gaussian splatting is the way to go with localized on-device processing of the environment, and then you match it against the physics of a world model. But then Gaussian splatting only gives you like a certain quality and quantity of the signal, and that you need something like a point cloud that would give you certain other signals that Gaussian splats wouldn't, and that you need to combine various layers in order to kind of get anywhere close to replicating what we as humans and what other creatures like dogs or cats or other animals or even birds would do very instinctively. So it seems to be that just like FSD, for full self-driving for Tesla and autonomous vehicles, this as we kind of the long tail of nines, but we haven't even got anywhere close to the long tail of nines. We're still peeling the initial layers of this problem, right? And with every layer that we peel, it seems to be more and more complex.
Don't you need to do some trial and error as well? I mean, you don't need I understand, or I learned that the second time I open the fridge, it gets stuck. I don't need to understand the physics that warm air is entered and then cools down and shrinks, so it gets like a partial vacuum or something. The bot could perhaps just tug it a little harder the next time, or is that extremely difficult to give it that lenience without it ripping the whole thing off the wall?
So there are several approaches, and we could talk about this for 5 hours, but there are several approaches. One approach is to give the robot an understanding of a range of operating. So you can say, kind of like we do, we assume that a cup, if you see a cup on a table, it's going to weigh a certain amount, right? And we just go for it, right? We pick it up and we kind of on the fly figure out the mechanics of getting that cup up to our face and drinking the liquid. A robot, first of all, the frequency of the signal going to these extremities and the signals coming back isn't the same as a person. So we can't have the robot go pick up the cup and dynamically adjust in real time to, it's not going to be hopefully not drinking water anytime soon. But we have to program the robots in a way to anticipate, what it's going to encounter. And then if it doesn't make that same quality of, that range, then we adjust. And so the next time it goes to pick up the cup, if we said to it, hey, this cup weighs X, we might be wrong. The cup might be now filled with lead. I don't know, whatever, so that might be in a cup. And so now the robot's going to take
even a box with objects inside that keep moving. The physics are dynamic.
Right. Yeah. So in a way, we have to give it a range of things that we consider safe and okay, and then maybe have the robot operate a lot slower to kind of to deal with its own internal communications about what's safe and what's not. And that's why when you see me online typing, you can probably envision how angry I am typing when I see companies that 10x their videos, and they make it seem like, oh, the robot is just moving in real time and it's so fluid and perfect. I know what they're doing to accomplish that, and I want to kind of change the mentality there so that we all tell the truth about either you've set this up so that the system works perfectly for that one object, and if I throw a new object at you, will the robot perform just as well? I'm 100% sure it won't. So
it's kind of like our pet peeve, right, Mehrdad and Gustav, that the edited videos, the cuts, show us the raw video whenever you're making a demo.
Or if you say it's a generalist, let's see some other objects, like you said before about the other ladders. Let's see if you can, walk stairs, walk all the stairs. Don't just say you can walk stairs blanket, but you can only walk this one set of stairs that you trained on. So I can go on. You guys, you guys know you hit a hot button for me. So,
but regarding Maddox, to be honest, I personally have a high respect for that company, mostly because they are performing in an industry that is extremely competitive, and they are trying to do innovation in such an industry that everything is about price, basically. That we have home vacuum cleaners that cost 200 euros, and why people should pay as their price point 1,400 for a robot that people can buy it cheaper. So they have
it's an industry that sucks.
It sucks. I've actually had a project in that area and I canceled it because it's just extremely about OEMs, supply chain, just standard components, and they're just getting away with that. So they are solving some problems. For example, you have all experience. If you have had vacuum cleaners at home, you see that if there's like wires on the ground, then it will get stuck. Or if there's a pet, it will scare off the pet. All these things. So they are trying to solve this. But the question is, so the point is, market never lies, right? So it's the market by the end of the day that decides if this robot is the best robot in the world or not. And then, to be honest, from all the statistics I've seen, they are not even on the top 20 of vacuum cleaner companies in the world. Why? Because their system is over-engineered and it's very unique and it's very expensive. Now, you say, if I add Gaussian splatting on board, which is pretty crazy, then of course you're gonna deal with a lot of computation, a lot of extra power or battery need, whereas the other competitors are just running everything on an MCU, on an extremely cheap MCU, I think like €5 or something, and with a, I don't know, $10 LiDAR. So you should be able to, I think in such a market, you should be able to adjust to your peers and competitors. And if you want to be exponentially better, you should have very good reasons for that. Whereas Scott said something during this podcast that was very interesting for me. He said, these are not robots in a term of like, how do we divide this? Sorry.
Yeah, I mean, we're missing Scott. I mean, I think we went over on our time with the other topics. I would have loved to have Scott's view on this.
For example, one thing that we always say about robots is that robots are bio-inspired systems, and nothing about the home vacuum cleaner is being bio-inspired. So now this is also very debatable. Oh, is it bio? Does it have to be bio-inspired or not? Yes.
I mean, if you have a humanoid robot that can just sweep the floor and swab the floor, effectively,
that is
all of these are going to be dead, right? So it's evolution there too.
I mean, the idea of robotic as a field, since it was created, it was bio-inspiration. Like that. That's what I'm debating on.
The word robot comes from like servant or slave. So I mean, it's vacuum or floor, so it is a servant.
Oh, that's great. If it's from that perspective. But now imagine. The point is, like, it just becomes an autonomous machine, right? So we should draw a line somewhere. If we say everything is a robot, then Alexa is a robot, Siri is a robot, Tesla cars are a robot, airplanes are robots because they also do autopilots and they have autonomy. It should have these three traits to call it robots, right? Being bio-inspired, zoomorphism or anthropomorphism or anything else. It should have intelligence in a sophisticated way, and it should have movement, actuation, degrees of freedom, right? Any system that has all these three, then it's a robot. Any system that is lacking one of them is not a robot. If we draw the line this way, then we can decide what we are talking about. But anyway, we talk about the vacuum cleaner robots.
That's a whole. You guys should have a whole show on that. What's a robot? And then the other thing I want you to answer: what is autonomy? What does that mean? And maybe another show, because we can talk about that.
The meaning of it is changing. So if this week we say autonomy is this, then next week we should have something else. Yeah. So it's like the definitions.
We should have midweek live streams on these.
Yeah.
In addition to the Sunday roundups.
15 years ago, AI was something completely different. You remember, right? AI was just, this is AI. It can recognize, I don't know, a pet in a photo. But nowadays, you no longer call that AI, right?
ImageNet.
There's
We've come so far from ImageNet.
Funny proverb. It says, as soon as it works, you no longer call it AI. Right? And so AI and robotic has always been this like dream vision for us. It's only in the past couple of years that we said, okay, now we have achieved it to some extent. But before
but just going back to the point of that I was asking Kibati about the complexity of world models and solving them, it just seems to be that all the robotic companies appear to be selling this dream of, generalized robotics is just around the corner. You've had Elon say, you're going to have robotic surgeons in the next 5 years, and again, and he's reiterated that. He said that recently again with Grokbot and Optimus, that you'd have the best healthcare. Are they selling us these pipe dreams? Because when you look at the reality and the physics of everything that's involved, it's darn complex.
I don't think so. I think that the time, anything that Elon says, you have to 3x it, right? In time. It does get it done.
No, but it's not just about Elon. It's about all bot companies in general. They seem to be wanting to outdo each other. And I'm wondering how much of their fundraising efforts are playing into that.
I started with that. I think, and my co-founder is going to hate me for saying this, but I don't like showing things that aren't real. And when I show up with my robot and its guts are hanging out and it's moving slowly, this is the reality for every one of these companies. The difference is what they're willing to show and what they want to tell investors. Investors want to hear a story that everything's already solved. But if everything's already solved, why do you need more money? if everything's already solved. But investors want to hear everything's already solved, and then the next time you come around for more money, you're going to layer on the new thing that needs to be solved. And so none of these robots are making it in production, but they're going through Series C, D, E, and F, right? But you said you're going to solve it in your seed. So how are you on Series F? Right? You didn't solve the problem. So it is. It's almost like a Ponzi scheme in a way. And the way I want to approach it is a little bit different. It's like, let's solve some problems today that we know we can solve. Let's not say we can solve something that is in the future. But I do believe that Tesla, Figure, 1X, all these companies are going to get to that solution. It's just not in the timeline that they say they will.
It's so ironic, right? When you think about it, we seem to be closer to cracking artificial intelligence, and we're way ahead of that in its digital form than we are in solving embodied AI. And
I can tell you why.
This despite the fact that we've had, like as Scott pointed out, we've had animatronics for centuries now.
But I can tell you why. It's because we haven't been collecting data from the physical world. And you made this point by talking about Gaussians and others, right? We just now started collecting all the data we need from the physical world. And actually, I don't want to say all. We just now started collecting some of the physical data we need. We haven't been collecting what humans actually feel when they're touching objects until the last couple of years, really. And so, I did something a couple of years ago where the robot had to pick up an orange, and it's a deformable body. It's super difficult to do, or like picking up a cotton ball, a needle and thread. Not that we want the robot to be able to do that, but I wanted to find out what it would take to make that possible. And what I realized is we didn't have any data from humans doing this thing that we've been doing from all through evolution. So I think we're now starting to figure out that we needed that data, and you're starting to see companies like, what's the hand glove company? I can't remember their name. I have a pair. Manus. Thank you. And so we're starting to see all these companies come out with ways to acquire this data, but that data is just now making it into the real world. And some of these companies are trying to sell that data, which I think is preposterous. Why would you do that? You should make everybody better by giving that data away. You'll get way more use. You'll get way more people buying your gloves if you sold the gloves at a reasonable price and then the data was free. Anyway, but we're not there because of that reason.
All right. Well, closing comments. Let's begin with you, Sarah, and then I have a philosophical end to this.
All right.
Let's begin with me. I've been in learning mode for the last 20 minutes listening to this conversation. So I guess, what I can say as a closing thought is that, to me, it's always a conversation very interesting and intriguing to learn about the series of the technological problems that we need to solve to get where we are all thinking that we are. And it gives me a lot of hope and optimism, because on the end of my work that we need to be solving are questions that are having ramifications that we cannot even comprehend today in terms of the implications that it will have on the humanity and the course of the humanity that we will be witnessing in the future. So to me, I think it's a great fact that we are still so far away of an adoption that we are all dreaming about, that we can learn from and ask ourselves to even this. I think, again, this technology is helping us to better understand what it means to be a human. It's pushing us to understand our own physical limitations, emotional limitations, mental limitations. It's asking us very deeply spiritual questions of will the robot ever have a soul, and if we will ever be able to look at a robot similar to what we can look at the human or animal, because we assign that it has a soul and it has this higher meaning. So I think that my closing thought is that I believe that we are sitting in front of the most interesting part of the human history, and I might be biased because I'm in it, but I think it's definitely going to push an envelope on ways that we maybe even now now cannot even understand how. And to me, that is an exciting opportunity to learn and to expand. So that's my closing thought.
Indeed. Gustav?
Well, we started with the Chinese Robotic Olympics. And I mean, I like this approach. I want them to really show off what they got. And I don't really know the incentives that they have to kind of push towards this Olympic competitions. But I really wish that they would put the dexterous tests or the hand tests at the forefront, because I think that's a big part. It's not the only part, far from it, but Scott always says the rest of the body is just putting the hands where they need to be. So I would really love to see them pushing that and hoping that that kind of competitive mode would drive the progress even further. So yeah, and I do think that we in the West should perhaps look a little bit more at what they're doing over there in reaching out and getting people engaged and enthusiastic, as enthusiastic as we are. I mean, we can't be the only ones.
Mehrdad?
Yes, so mine could be very short. So I think most of the humanoid robots today are as their capabilities is as much as a 3 or 4 years old baby, but a baby will grow someday. That's inevitable. So
Kimati?
Wow, I'd love to respond to everybody's comments because they're really cool. But I'll say, Sarah, one thing that I find interesting is at what point is a robot is it something that is not unlike us and shouldn't have the same rights and protective measures? What makes us human and conscious? And at what point would a robot be considered that? I mean, that's one of those existential questions for sometime in the future. But at the point in which a robot can dream, which is already happening, and has goals and aspirations that aren't pre-programmed, at that point, what's the difference between that and a human? So maybe I'll leave that for another time. But in closing, I think we're very, very close. We're on the precipice of something great. All these technologies coming together, China inspiring from a physical perspective, from the actuation, hand development, all of these things. The United States has really been, inspiring the world as far as like vertical integration in a full stack development of these robots. And Europe is starting to grow in all these different areas. I'm super excited about some of the companies I'm seeing. You mentioned UMA, super excited about them in Europe, and Neuro Robotics, super excited about them as well. I think this is a ChatGPT version 0, whatever it was that came out at the very beginning. This is that moment. We're not even close to where these models have gone to today. We're at day one, making haikus and poems with 6-line haikus. That's what we're doing with robotics right now. And I think we have to be very, very aware that there's a long tail to this. There's safety that we haven't really talked about. There's privacy. There's, like you mentioned, the emotional responses that might be, elicited by these robots, or even what a robot might make us feel about ourselves. Like if we have a robot that one day looks like a man or a woman and is better than us at some of the things that our partner might want, that's very scary. But it also might cause a ton of divorces, and it might cause a bunch of people to never get married. So I think talking about this is great. I think the governments around the world should also be talking about this, and I think they're not as informed as they should be about where this technology could go. So I'll stop there, and I'm working on that. But I'm hoping that, I know Sarah's working on that. I know Mehrdad is working on that as well. So these things, we need to make sure that the bigger companies don't just impose upon us a robot that we now have to react to, because ultimately that's what people will do. Those who accept it and react. And it'd be better if we can create a world where the robot is doing the laborious jobs that we don't want to do, the 3Ds, dull, dangerous, dirty. We want them doing that. And we want us, doing the art and, the dancing that I'm starting to see robots doing. We want to do that. We don't want the robot doing that, right? Even boxing, I'm like, you're just controlling with the buttons. Like, is that important, for us? So anyway, I can go on a monologue. You guys know that, so I'll stop there.
No, I mean, look, you guys got me thinking, and I'm going to end on a philosophical note, but this whole question of world models, and I would offer a quote by this 19th century Scottish author George MacDonald, who very philosophically and deeply said, and I quote, "You don't have a soul, you are a soul, you have a body." And I think a lot more roboticists and engineers trying to solve the world model problem and the whole problem of agency in humanoids and other form factors perhaps need to think about that a bit. Maybe there's something there to think about, because it does reflect the human condition in so many ways.
I thought you were going on old MacDonald, that he had a farm, but
E-I-E-I-O.
I know you were ending, and that was very deep to think about. What separates us from?
You should have ended.
You should have ended. But what separates us from some of the animals that we consume? We consume these other life forms, right? They some of them have consciousness and thoughts,
But
right?
not a soul.
Yes. Okay, so but is it something that a robot, if a robot came up with all these other these other factors and it wanted to live,
Does it
what
have a
would we
soul, or is that just self-preservation?
We don't know.
I think we should leave that for another live stream.
Yeah.
And I think Sarah will have a lot to say about that, right, Sarah?
Yeah, I'm like really struggling not to say anything right now because I know we have to go. So,
but we must talk about this, because these are fascinating aspects of. I mean, it's great to talk about, the engineering and all of it of robotics, but there are so many other dimensions to all of this and how this impacts our lives and societies, and will continue to only increasingly in the future. So I'm hoping we can continue to do that on these live streams and the chats on Over the Horizon, because as the name goes, we love to look over the horizon. And with that, thank you, Sarah, Gustav, Merdad, and Kimate, and Scott, of course, who spent a great chunk of his day with us. Thank you all. Till next time.
thank you.
you guys.
Bye.